All right, everybody. Here we go. Let's go over some questions here. Second half of your quiz. Remember, this review packet here at the end of the workbook is for the entire unit. Remember, you already got quizzed on some of this stuff. So, what am I going to do here with you guys? Yes, this was on the second half here, page 59. Let me start with part B. I'll do both parts because it has both even and odd multiplicity. Page 59, part B is where we're starting here today, ladies and gentlemen. All right. The degree here is the highest exponent of this polynomial function in standard form, right? This is in factored form. So remember, if we were to multiply this out, right, we have an x from the x minus 1, and we have two x's, right, with the x plus 4, because it's raised to the power of 2. So that's an x to the power of 3 if we were to multiply that all out, right? That would be the first term. So this is a third degree polynomial function with a positive leading coefficient. And like I say, you can also put the number in there if you want to, right? It's, you could also write a 1 in there. The y-intercept, algebraically, is when x is equal to 0. So you put in 0 for x into the function. So it would be 0 minus 1 times 0 plus 4 squared. Negative 1 times 4 squared is negative 16. Zeros and the multiplicity, if it applies, remember multiplicity begins with the repeated root twice. That's where it starts. Multiplicity of 2, which is even multiplicity. If you set the factors equal to 0, right, you look at the factors here, you're going to get x equals 1 as a root, right, if you set x minus 1 equal to 0. You set x plus 4 equal to 0, you're going to get negative 4 as a root, but that is getting repeated twice, right? That has a multiplicity of 2. That is even multiplicity. Remember, you can use the exponent of what the factor is raised to determine if it's even or odd multiplicity. All right, so what's the general shape of this guy going to be? It's a third degree function, so it's a cubic function. Odd powered function, meaning the end behavior is going to be different. Positive leading coefficient, right? So it's going to end high. That's how I think about it. Start low, end high. That's going to be the general shape. All right. So let's plot out the points here. What do we have? We have 1, right, as a root. We have negative 4 as a root. And we have negative 16 here as a y-intercept. All right, so here we go. Let's start it low and end it high and take into account the multiplicity. All right, so start low, right? Once we get to -4, look at the multiplicity. It's multiplicity of 2, meaning it's going to be tangent to the x-axis there at -4, right? Then it's going to go to the next point here, right? -16, and 1 is a simple root, meaning it goes straight through, and it's going to end high, and there you go. Right. And once again, remember it's a sketch here, and they're asking us the end behavior there at the end. As x goes to infinity, f of x is going to what, right? What is the function? What is the y going to? As x gets bigger and bigger and bigger, as x goes to infinity. Now keep in mind here, it doesn't go straight up. You know, over time on the x-axis, technically this just gradually, you know, widens to the right. And this gradually widens to the left. You know, just saying. It doesn't go straight up here, even though, you know, when you look at a cubic graph, most times it kind of looks like that. But over time here on the x-axis, it gradually expands, it gradually widens. So, just saying. So as x, gets bigger and bigger and bigger, the y is getting bigger and bigger and bigger, right? So that's going to infinity. And as x goes to -infinity, the y is getting smaller as well, right? The y is going to -infinity. So, right, so I'm just going to, you know, just note this for you guys, right? This is x going to infinity, and in that scenario here, the y is going to infinity. Over here, the x is going to -infinity, and as x does that, the y is going to -infinity also. All right. So that's one with even multiplicity. Let's do odd here. We'll do an odd one. This is 1x here with the x plus 3, and 3x is here. All right, the x minus 2. That will multiply to x to the power of 4. So that is a degree 4. All right, polynomial function with a positive leading coefficient. Remember the general shape here. For a quartic function with a positive leading coefficient will be a W shaped. Okay, graph. The y-intercept, you put in 0 for x, right? So 0 plus 3 multiplied by 0 minus 2 cubed. -2 cubed is -8 times 3 is -24 is your y-intercept. Set the factors equal to 0, you know, to find the zeros. You would get -3 as a 0. And 2 as a 0, that's getting repeated 3 times, right? That is your odd multiplicity. All right, so, once again here, let's plot the points we have, the x-intercepts and the y-intercept. -24 here. And let's sketch the graph. All right, W-shaped, take into account the multiplicity. Right, so -3 here is a simple root. It's going straight through, goes to the next point, which is the y-intercept. Now keep in mind, multiplicity of 3 here, right at x equals 2. You're going to have a point of inflection there. You know, like I said, if you want to label it, if your point of inflection doesn't look that great, okay, you know, just to make sure, you can do so. And, you know, there it is. So like I said, that's, the, you know, what I have here is the general shape, right, of a quartic function. It depends on the roots and the multiplicity. You're going to get some variations. Now, the end behavior is going to be the same. It's just, you know, what you have in the middle is going to, you know, it just depends on, you know, the roots and, like I said, the multiplicity. But the end behavior will be the same. You know, whether it's a positive x to the fourth, you know, or a negative x to the fourth, the end behavior will be the same. It's just the stuff in the middle, the interior. As x goes to infinity here and x goes to negative infinity. All right, look at the end behavior here. They're both the same. All right, both going to infinity. All right, there, ladies and gentlemen. Both going to infinity, right? As x gets bigger, so does y. As x goes to negative infinity, remember, right? This is gradually expanding, remember, over time. So this is x is getting negative and more negative and more negative as it expands to the left, right? And that's what it's doing there. All right. All right, very good. Let's see what else. What else do we got going on here, people? All right, is there one given the graph, writing the equation? That's just naming the degree. All right, so let's do this guy here, part C. I'll probably do parts A and B as well. So given this graph, we want to write the equation. That's what I want to do here. Page 62. Given this graph, write the equation. So we're working backwards, right? We're working backwards here. 2 is a root, meaning x minus 2 is a factor. Negative 2 is a root, meaning x plus 2 is a factor. Now they're both tangent here, right? Positive 2, negative 2, both tangent to the x-axis here at those roots, meaning even multiplicity. Those roots getting repeated even number of times, right? Now, this is a quartic function, so I know the multiplicity is going to be 2 here and not 4. Right? This is a quartic function. You know, a negative with a negative leading coefficient. I mean, we'll find that out there in a second, but just, you know, in terms of the degree of this function, it's an x4. All right. So what do we need to do? We need to write the equation, right? We need to write the equation of this function. Remember, the one thing also in addition, well, yeah, I know it's going to be a negative leading coefficient. I got to find out, you know, is that going to be like a -1 or a -2 or what have you, right? So that's the one thing here, right, we need to find, right, is that, you know, stretch or shrink factor, which I believe I, you know, referred to in this lesson, which you don't need to know right now, but that leading coefficient. So we need to solve for that, and then we'll put in the factors here. All right. And then we're going to put in a point, right, into this equation for x and y so that we can solve for a. Remember, it cannot be a root. A root will not get you that a value. If you remember, you'll have 0 equals 0a. So we do have the y-intercept here. The y-intercept will be good, right? If you plug in 0, -2 here into this equation, that should help us solve for A. And like I said, it should come out to be negative here, right? Because the end behavior is going to negative infinity for both here. So -2 is going to equal A times 2 squared times -2 squared. -2, that's going to be, what, 4? And another 4, right? 16A, would you say? And there you go, -1/8 is your value for A. Like I said, you know, when we did this, that will go back right into the original there to write the equation. All right, so y is going to equal -1/8 times x plus 2 squared times x minus 2 squared, and the order does not matter with the factors. And that is the equation, okay, for that function, people. All right, for part C, what about parts A and B here? Name the degree and the zeros of each. Tell if the leading coefficient is positive or negative. So they don't want you to write the equation here. So part A, end behavior is different. So it's an odd, right? It's an odd-powered function. So it's like an x3 or an x5, you know. You look at the roots to determine that, right? If there's any multiplicity here, you know, with these roots, then I might say it might be an x5, but those are simple roots. There's no repeated root there, so I would say x equals 0 is a root. X equals 2 is a root, and x equals 5, since it's not, none of those roots are getting repeated. There's no, you know, it's not tangent to the x-axis, right? There's no point of inflection there. You know, this is a cubic, right, which is a third degree polynomial function with a positive leading coefficient because it ends high, right? That's what I use for the odd-powered function. It ends high. If it ends high, it's a positive leading coefficient. If it ends low, it's a negative leading coefficient. All right, let me do part B, and I think that might be it, you know, for this. There's, you know, not much to the second half, right, of the unit here. So x equals 2, right, is a root here. Right? 2 is a root. 5 is a root. Doesn't get repeated. So this is a second degree polynomial function. And behavior pointing up here, right, with an even-powered function, right? If the end behavior, the hours are pointing up, that's with a positive leading coefficient. And what else here? The degree, second, yeah, zeros, 2 and 5, not getting repeated, right? Once again, there's no tangency point there. There's no point of inflection. And a positive leading coefficient. All right, and there you go, people. All right, like I said, that's about it, you know, with the polynomial functions and, you know, what I did in the first part here, minus the, you know, finding the irrational roots, doing the identity stuff. was on this second half, you know, so, and I think I did number 18 somewhere else in this packet. So the identities, you know, given the graph, write the equation, and given the equation, sketch the graph, right? I think that's really about it here with this